So my name is Frank Wuerthwein. I'm a professor of physics at University of California, San Diego. I'm also the Open Science Grid Executive Director, the Open Science Grid being a national consortium of IT providers, software providers, and science stakeholders that operates and runs and uses the computing resources across universities nationwide. Scientific computing is essential in a way that modern science is effectively no longer doable without it. In fact, the way I'd like to think about this is, if you ask yourself what used to be the binding glue of a university, then for hundreds of years that was very obviously the library, because the library was curating information in order to enable the creation of knowledge. And I would argue that today, at least for science and increasingly also for social science and other domains, it is research computing that has that status, in that it subsumes all the services required for a modern university to curate information and processing capability of information in order to derive knowledge out of information. The areas of scientific computing that are of specific interest to me are what I call high throughput computing. And what I mean by this is essentially anything where the computing is driven by automation. So one way of thinking about this is any scientific quest that would benefit from many individual actions, computational actions, whether it's data transfers or jobs to compute, that are mutually independent and therefore can be scheduled independently, and therefore fundamentally depends on automation. Those are the kinds of things that are of interest to me. My favorite computing tools are those that enable high throughput computing. And in the most obvious ones are HT Condor. Then there is things like CVMFS to establish a runtime environment that is commonly across resources. Then XRD and GridFTP as data transfer infrastructures, and in XRD's case, there's a caching infrastructure as well for wide area network data federations. Then what else is obvious? I think those are sort of the immediately obvious ones. All memorable technical challenges revolve around making stuff work. And it's, in a funny way, the more memorable, the more challenging it is, right? I mean, you remember mostly the things where things really went south, and when you had to overcome problems that involve multiple types of different things, from hardware to firmware to software infrastructure, etc. So those are the kinds of things that tend to be remembered for a long period of time, when things fail catastrophically in ways that was really painful. Biggest challenge and opportunity is to try to create a global sharing infrastructure or global transparency of allowing people to function in ever larger global collaborations, where individual scientists or institutions can contribute resources, whether it be human or hardware or services, into a common infrastructure that the entire collaboration shares, in such a way that you enable local control and local priorities, but at the same time giving a global view to the collaborative effort. Mm-hmm. And those can be things that are just two institutions, or two PIs from two different institutions, or even two PIs from the same institution. Or it can be truly hundreds of scientists or thousands of scientists from institutions all over the world that pitch in order to achieve a goal. And creating structures and creating the means for such distributed collaborations to have a common infrastructure that they can contribute to, and including buying their contribution via commercial providers or adding allocations that they might have, and so that you have a truly diverse set of business models and diverse set of resources, and bring all of these things in order to achieve a scientific goal. Those I think are the challenges of the future that I find the most interesting. Never lose sight of the primary goal that you have, and it's called scientific computing for a reason. Yeah. And so that you don't want to be too enamored of the more better technologies, the more better things, the more better tools. You want to be focused around the primary objective, which is ultimately the science that wants to get done. And don't forget that that is really the driving force of what this is about, and not get lost in rabbit holes of technology and lose focus as a result.